Oh, hello out there? Anybody home?
Hello.
All right. I can hear you. That's terrific. We had a problem on Monday. I don't know. This actually didn't happen at the very beginning. At some point after break, no one could hear me. You could hear each other. So I didn't know how to fix it. So what I did was I figured out what worked is created a new meeting real quick and killed that one. And that seemed to work. But hope that never happens again. Or maybe I can learn a way to fix it. It was kind of annoying. Nobody could speak. Well, I mean, they could speak. I couldn't hear it. All right, go. Okay. All right, dead man walking here tonight. That's me. Got bronchitis. That's exciting. And now I've got a fever. That's even better. So hopefully this ibuprofen will kick in and we'll see what we can do here. So hopefully I won't be babbling incoherently or anything like that. So I hope it's not that stupid COVID. I hope it's just something else. I've had bronchitis before. It's been a couple of years, but I'll try to turn away when I cough because I cough way louder than normal with bronchitis. So it might frighten you if it goes directly in the microphone. So at least it can't make you sick, right? So you're safe. So all right, let's see what we can do here. Now the plan, I was going to do this anyway, even before I wasn't feeling too well. Is that we have three sections left. You know, instead of doing a full load today and only a partial load next week, I was going to kind of break it up into, you know, where I did the first section and there's a good stopping point halfway through the second section and then do it next week. So what's going to happen is we'll just have two shorter than normal classes instead of one lengthwise, instead of full length and then really short, you know, that'll count on this way. There'll be kind of a compromise between the two. So we're going to finish, at least lecture wise. I mean, obviously if you're asking questions and stuff, that's fine. But lecture wise, we're going to be done way earlier than normal tonight. So, but we've almost got it wrapped up here content wise. So 3 more sections and that's it. I haven't given much thought to the next exam yet, but obviously we'll get something going here. So maybe I get a couple more days for, you know, to become a little more coherent here. So, all right. Hope you're having more of a lovely day than I am here. So let's see what we got. So let me share a screen for us here. That's not the screen I was going to share. That's okay though. Let me try this again. That didn't. Let's see. Let me stop sharing. I didn't see the green bar around it. Let me check again. I'll let you tell me. Okay, it's probably all right. I don't see the green bar, but it's probably okay. So do you see something called intro to hypothesis testing?
Yes, sir.
All right. Thank you so very much. I appreciate it.
Sí, señor.
Oh, thank you. Muy bueno. Thanks for helping a dead man out here. All right, let's see. Yeah, this has a lot of kind of conceptual intro versus the confidence interval that we did. Because the confidence interval, once you kind of get it going, you know, it's kind of straightforward every time. The only difference is kind of whether you're choosing a T or a Z. That's the only difference. We're going to have T and Z here. But there's a lot more. This is a little more challenging, you know, not mathematically, but conceptually. Nothing in this class is really challenging mathematically. It's just word-wise can be. Okay, let me take a drink of something here. Now, this is part of, you know, last week I mentioned that confidence intervals, there, you know, that's a part of what's called inferential statistics, where, you know, we're using sample data to make a prediction about the mean. Well, we're doing the same thing here. We're just doing it a little bit differently. Instead of trying to put the mean in a particular interval, we're actually trying to compare the mean to a specific value. And maybe it's greater than, equal, less than, that sort of thing. You know, we're comparing it to a specific number and then using sample data and deciding whether or not, you know, we refute that evidence or not. All right, so let's take a look at this. So every hypothesis test has a pair of hypothesis statements. They always come as a pair. We have the null and the alternative. I think that's technically a 0, but I just call that the ho. It's more fun that way. We got the ho and the ha. Some books call it H1 or whatever. I'm not even sure what this book does. I'm not changing it just for the book, but just in case, H1 and HA will be the same thing if it appears that way in the homework or something. So anyway, the ho is going to be some sort of a statement of equality. It's going to be something where it's less than or equal, greater than or equal. The ha is a statement of inequality that is the complement, or which we learned back in probability. That's the opposite. Complement's the opposite of the ho. So less than or equal to will pair up with greater than. Equal will pair up with not equal. Greater than or equal to will pair up with less than. They always, in fact, we come down here. Now, anytime you set up a hypothesis statement, it's going to look, it's got to be one of these 3 forms. That's it. Now, the mu zeros here are numerical values. The mu is just your variable showing, okay, we're claiming the mu, blah, blah, blah. But the mu 0 will be a number when we start doing real problems here in a minute. But it's always going to be one of these 3, and it's got to be in this order. You can't just flip-flop them. Like for this last one, if it was equal, not equal, you can't just flip them. The ho has to be the equal, and the ha has to be the not equal. You can't just, so if you were looking at choices on an exam or something, and which is the correct statement, and if one of them had the not equal as the ho and the equal as the ha, that is completely impossible. Let me write that down. So if you saw, I keep forgetting my stylus here, but they have to follow that pattern. So this would be, I'll just make up a number because the number is not important here. It's the symbols. So that's a big fat no-no right there. It can never be written that way. Has to be written in the form that's those 3 forms. All right. So if you saw an answer choice that looked like that and go, why, isn't that the same thing? No, it is not the same thing. All right. So I'll be kind of scrolling back up to these. I don't expect you to automatically just commit these to memory here. You'll be able to look at them, obviously, when it's time to do homework or an exam, but because obviously we'll be using these whenever we're looking at some of these examples down here. Okay, because they come in these pairs, any problem has only they only have to give you one of the 2 pieces of information. And that's called the claim. Sometimes the claim will be the ho, sometimes it'll be the ha. Because all I do is give you one of the 2, and then you know what it has to pair up with. It automatically has what it pairs up with. So they don't have to give you both. They just have to give you one because it's got to fit one of those 3 pairs above there. So we're going to see that here in a minute. So like I said, the claim can be either the ho or ha. It's just whatever they give you in the problem, whichever one of those. It's going to be one of those. It's going to be wording to represent one of those 6 symbols right there. One of those 6. Okay, I don't try to like to get too tricky on this. I don't know what the homework does, but I certainly don't try to get too tricky for exam purposes. But we're going to kind of need to realize some things like, is or of means equal. Is not, differs from, would be not equal. I doubt if I would use not less than, but maybe the homework word I would probably use at least. But either one of those, both those wordings, at least or not less than, represents greater than or equal to. Fewer than, less than. Okay, just regular less than. No more than, or at most, I would probably use at most, and so maybe, I don't know, maybe no more. But both of those kind of represent less than or equal to. Meaning at most means you can actually touch that number. Less than means you can't. So now, unlike when we were doing the normal probabilities and stuff, the equal symbol didn't matter as much like it did for the binomial and the discrete. Well, now it's coming back into play where that wording is going to make a difference now. Not mathematically, just the way you set up the questions. More than or above. Okay, I think that's straightforward. So if anything comes up, just, you're looking at something and you're not sure, just, send me a delightful message and I'll see if I can straighten it out for you there or whatever. So if something weird comes up in a problem, like I said, I don't try to make my exam problems too weird. Okay, let's see what we got here. Write the appropriate hypothesis statements and label the claim. A consumer analyst reports that the mean life of a certain type of automobile battery is 74 months. I'm going to scroll down here in just a second. So is, what do we think is means? I think is means equal. What do you think? Is means equal. Then to set this up, you go back up to here. And you see that equal is a hoe. So it would have to be written as the hoe, and then it pairs up with not equal. And I'm just labeling the claim right here, just to show you, like I said, one of the two. It could be either the hoe or actually the next one, the claim is going to be the ha, the alternative. It just depends on whether the wording in the claim is giving you one of the three hoes or one of the three ha's. Equal, not equal. How about that? Isn't this fun already? Okay, company claims its brands of paints have a mean drying time of less than 45 minutes. Less than is a ha, right there, the first one. It automatically, every time, would pair up with greater than or equal to. Less than, greater than or equal to. And then there it is. But see, I'm labeling this one as the claim because that's the one it's giving us in the wording of the problem. It's giving us the less than. So that's why I don't know if that's going to be that important on a test, that worrying about labeling it the claim. I'm just doing that just to show you. We'll see if that comes up anywhere in the homework or whatever, but I don't make a big deal out of it really for testing purposes. But you claim that the mean score for NBA games for all particular season was more than 100 points per game. Okay, more than is greater than. Greater than is a ha, and it will pair up with less than or equal to. All right. Now, and this is going to come back, obviously, when we start doing some, real problems between, some today and then more so next week. But that's just the basic idea of, sort of reading them and setting them up. But we're going to be doing more of these whenever we do actual problems. Type of errors and level of significance. Now when we say errors, once again, it's not an error as in you, the person, making a mistake. It's, of course, confidence interval errors are easy to explain because that's just, in other words, we talked about that last week. If you do a 95% confidence interval, that automatically, by definition, means there's a 5% chance your interval is not right. That's the idea, 100 minus whatever. So that's kind of built in. Here, we got a couple of types of errors here. This, like I said, this is a little more sophisticated. I won't lie to you, and I'm going by students too, this will be a little more challenging than the confidence intervals. But I got confidence in you. Now, when you perform a hypothesis test, we reach one of the following conclusions. We either reject the null hypothesis or fail to reject the null hypothesis. Okay, I'm going to explain this carefully here. So we're either going to reject the hoe or we're going to fail to reject the hoe. Now, we're going to talk about this. Failing to reject the hoe doesn't mean we accept the hoe. It doesn't mean we love the hoe. It just means we don't have the evidence to say it's wrong. And we'll talk more about that as we go. Because the idea in these statements is it's a lot stronger result if you can reject the hoe in favor of the alternative. Failing to reject the hoe, as you might think as a statistician, The whole statement might be okay, but I'm not totally, enamored with it. So, all right. Okay, so we're gonna build on this a little bit, but no, because usually people will ask me, isn't it the same thing as except? It's a slight difference here. I got an example I'll show you that's not even mathematical. I bet you didn't think today you were going to hear hoes said all over the place today. There were you. Sort of feels like Christmas season, doesn't it? Ho ho ho. A little early.
Yeah.
We haven't had Thanksgiving yet, but all right. Like I said, this is a little tricky. All righty, let's see. So I like to, ham it up a little bit, have a little fun with it. Now, once again, these two errors are not mistakes that you make as a human being. They're process errors. So there's two things you can do that are wrong here. If you reject the null hypothesis and it turned out being true, a lot of times you're not going to know this. That's the idea. Just like in a confidence interval, you're not likely going to know in a 95% confidence interval whether or not your mean is in there or not. Because if you could actually get all the data, you wouldn't even need to do the confidence interval. You'd just be able to average it up and say, here's the population mean. So it's kind of like, it's kind of strange, but it's an error, but it's an error you won't necessarily know whether it occurred or not. Yeah, if you rejected that hoe and that hoe was true, that's a type 1 error. A type 2 error occurs if we fail to reject the hoe and the hoe was wrong, meaning we did not reject. We agreed with the hoe. Well, we didn't reject it. It doesn't mean we agree with it. Let me clarify myself there, because I just told you that doesn't mean we accept the hoe. We failed to reject, and it was false. The hoe was false, and we did not reject it. You don't have to worry about, okay, we're talking about this alpha thing we're going to talk about. Not a big deal. No, we're not worried about this probability of type 2 being beta. So what are they telling us here? I wouldn't ask you directly anything on a test here, but I just copied this out. Type 1 error is like a false alarm, meaning you rejected it when it was true, and you said, said the alternative was true and it wasn't. That's kind of a false alarm. And this one's saying a missed opportunity, meaning that you did not reject the hoe when you had the opportunity based on whatever the alternative was to, take corrective actions and whatever the process was or whatever. So, okay, so let's take a look at this little chart here. So we kind of meet up by row and column here, as you can see, sort of, let's say, if we did not reject the hoe and the hoe was true, that would actually be a correct decision. That would be right, wouldn't it? You would not want to reject the hoe if it was true. Now here, we just learned that so if you reject the hoe and the hoe is true, type 1 error. You come over here, you did not reject the hoe and the hoe was false, you made a type 2 error. Then you come over here and you rejected the hoe when the hoe was false, that would be the correct thing to do. Now these aren't equally likely probabilities, thank goodness, because if these are all 25%, it's almost like, what's the process of doing, what's the point of doing this? You might as well just guess, or something. But these are going to be, so unlike confidence intervals, these alphas, that's the probability of making a type 1 error. It's called the level of significance. It's a Greek letter alpha. That's the kind of thing that's got to be given to you in a problem, just like a confidence level. In other words, you can't be asked to do a confidence interval, without knowing, what's the percentage. Same thing here. Now I just mentioned some common ones are 0.01, 0.05, 0.10. So we're not going to analyze in this class worrying about making a type 2 error, because you can get more advanced and do that, but this is the more common one, is worrying about making a type 1 error. So these are just common values. They don't have it can be anything. We see that they're low probabilities though of making those errors, which is good. You don't want those to be a high chance. Now here's, this comes into this, I'm using this criminal justice system thing here. I'm certainly not a criminal justice teacher, so I don't know anything about that, but I do understand this well enough. And this is kind of further explanation of the idea of failing to reject the null, the hoe, doesn't mean you accept it. All right. Okay, theoretically, this should work like this. The null hypothesis should be the defendant is innocent, and the prosecution is supposed to do their best to refute that and come up with the evidence to reject that in favor of guilt. Now let's look at the two types of errors that can be made in this process. Just in words, no numbers here. Type 1 means you rejected the hoe when the hoe was true. See, that's bad. That means you rejected their innocence and you found them guilty. That's bad. We don't want that to happen. That's no good. I mean, it's probably going to happen, but hopefully, in the era of DNA and stuff like that, it's probably less likely now to happen than it used to be with science. But so they try to do the process is supposed to be where that kind of happens least amount of possible. The type 2 error is probably going to happen way more than the type 1 error. Once again, I'm not a criminal justice expert, but if you failed to reject the hoe and the hoe was false, meaning you did not reject their innocence and find them guilty, that means they were guilty, but you found them not guilty. That's a type 2 error. So in other words, guilty person kind of got away with it. And you got to hope, I'm not trying to get in a big, moral discussion here or whatever, but the occasional guilty person is going to get away, but you certainly don't want innocent people to be guilty. But anyway, long story short, talking about that the hoe, let's say if you don't reject the hoe, and let's say it was not an error, let's say it was correct not to do that. And let's say you didn't reject their innocence. If you watch any kind of like legal shows, any kind of like Law and Orders or whatever, or this, that, and the other, you notice when they read the verdict, they don't use innocent or guilty. They use not guilty or guilty. And what that means is, okay, you did not reject the hoe of their innocence. It doesn't mean you love their innocence, but you did not have the evidence to reject it to find them guilty. Does that kind of make sense? You're saying that, okay, but that, as far as the defendant goes, they're free to go. You don't have to say innocent or not, but you don't have the evidence to reject their innocence, even if there's a small chance, you think they might not be innocent, but that's why they don't use the wording innocent. That's the same kind of thing. So failing to reject the hoe does not mean you accept the hoe completely. So hopefully that's not too weird or whatever. That's just kind of, because sometimes people like in, live class, they're a little bugged by that, kind of what that means. But not so much this example, but the failing to, because they'll usually tell you, first time I talk about the failing to reject, they'll go, isn't that the same as agreeing with it? Not quite. Close, but not quite. All right. Now, these are interesting. Oh, yeah, people hate these problems. I guess I shouldn't tell you that before I show them to you, should I? But, we might see a couple of these on exam 3. Oh, yeah, these because you got to really think here. There's really not any kind of math here per se. You got to really think through this. Let's take a look at this first one. So, okay, they're using H1. I got this from another book somewhere. So H1 is your ha. So we got a hoe of less than or equal to, a ha or H1 of greater than. So okay, less than or equal to always pairs up with greater than. So we're testing this. What will be the result if we conclude that the mean is greater than 47 when the true value is actually 52? Now let's think about this. A lot of times you may not know that, but it's just asking in theory what would happen here. Kind of wish the answers weren't there. I wish they were at the bottom of the page or something. That's okay. So you rejected less than or equal to. In favor, you support the greater than 47. Well, if they're telling you that the mean was 52, then that would have been the correct thing to do because it was greater than 47. So that's why you've made a correct decision. Now, you ready for me to twist this one up a little bit and have some fun with you? All right. I'm going to see if you can, and that's okay. Don't worry about it. We're just learning this. I don't expect you to. I'm just curious if anybody wants to chime in. If you don't, no problem. What if I leave everything the same in this problem, and I change, can I not write on this? Let me see if I can write with the mouse thing. Okay, I can do it this way. Let's change the 52 to 42. Now, obviously, I would expect you to have to look back at those definitions to be able to see which one it was. And I can guarantee it's not A. And you'll never have a none of the above on these kind of questions either. I just picked this problem because I like it. I don't like that. It's going to be one of those three. So it's either going to be a type 1 or type 2. So let's kind of scroll back. Let's see what we did. Then we'll pick. So if it's now 42, and we're saying that we concluded that the ha was true. We rejected the ho, in other words. If we rejected the ho and it really was less than 47, like 42, what did we do? Let's go back up here. If we rejected the null hypothesis when it was true, we committed a type 1 error. We rejected the ho when the ho was true. The ho became true once I changed that 52 to something less than 47. It was still the same answer, the correct, but that 42 now changes it to this. Isn't that exciting? All right. It's hard to tell, I don't need to be looking at people. That's okay. What I'm saying, like in a regular class, I can sort of look at people's faces and see what's going on. But you don't need to put your face on there. Don't worry about that. But I won't lie to you, it's a little tricky. All right, how about this one? Well, they got the ho and ha already set up for us. And let's see, we want to check whether the mean running time has increased. So the hypothesis, the ho and the ha, so has it increased, been greater than 9.1? Okay. Now here's a little trick on these that you can go back up at this flow chart here. If the question says, well, not a flow chart, that's not a flow chart, sorry. This chart right here. Notice if you look at the rows here, notice that if you reject the ho, the answer has to be either a type 1 error or correct. So don't pick type 2. On the other side of that is if you do not reject the ho, your answer is either going to be correct or a type 2 error. So right off the bat, whether it says reject or do not reject, you're eliminating one of the three. See, correct can possibly occur with either one of them. You see, correct has two ways it can happen. But so we've automatically, just by doing this will come in handy for you. Just use this, and you know it's going to be type 1 or correct. So let's go back down here. And this one didn't give us a number this time, but it says that the mean running time has not increased. That's just a fancy way of saying that this is true. It's still less than or equal to 9.1. It did not go up. So we rejected the ho when the ho was true. Therefore, that's why it's answer C, a type 1 error. Ta-da! Yeah, sometimes people will ask me, you're not going to put half the test on this, are you? And maybe a couple, but no, don't worry. Let's see. SAT scores equal 500, and then not equal 500, SAT math, SAT. Okay. Now, once again, let me highlight this part right here. Non-rejection of the null hypothesis. Fail to reject, non-rejection. All right, what that does automatically, what that does is this answer is gone. Remember I showed you in that chart. See, non-rejection can only correspond to either correct or type 2 error. Now we have to see whether or not it was correct to not reject it. All right. And we can get that information from right here. All right. That's saying this is true right here. So we failed to reject the hoe when the hoe was wrong. And that's a type 1 error. If the wording there had said has not changed from the 1990, has not changed, then it becomes a correct decision, because then you're saying equal is true. Boy, you got to be really careful there when you look at that, don't you? All right. Okay. That's kind of nice that we're kind of splitting this up in a couple of weeks. So I can go kind of slower than I normally do, a little bit slower. So still going to have shorter lesson today anyway. So statistical tests and p-values. Okay, now we're getting into something, let's look at normal curves and let's see what our calculator can do for us. And like I said, this section is a lot of preliminary work, like I was telling you, a lot of terms and things to get going. Next two sections will most be, pretty much be calculation based, and stuff. So, all right. Now we're getting to the idea, suppose we have, sample data, we'll be getting to that, where we have, means, same stuff we had for a confidence interval, all, mean, standard deviation, whether that's going to be population or not population, that's going to dictate whether it's Z or T, just like for the confidence interval. So that'll be the same. At least that's consistent. That'll be good. And then we'll see how to calculate that and decide whether or not, the hoe's got to go or the hoe's not rejected. Okay. Combine this with the level of significance. That's that alpha, the probability of making a type 1 error. That's a number that's given to you in the problem. That also has to be given. So it's not something you have to worry about. I don't know what that's going to be. This is always a tricky thing to explain. I got one of these days I got to come up with a good way to really explain that. I mean, I can explain how to get the p-value straightforward enough, but as far as what the p-value means, I looked at a YouTube video that was kind of interesting one time, kind of an entertaining little cartoon video that wasn't too bad, but I don't think I'll bring that up right now or whatever. But the good news is it's okay if you don't grasp this definition. I'd like to put the definition in there though, but let's just see what it comes about to be here, and I'm not even going to read that definition. But once you see what it is, it's not so bad. But the definition is kind of tricky. But it's important, though, because it leads whether or not we're going to reject or not reject. Now, those three hypothesis tests we told you, they got to come in 3 pairs, like I showed you there on the first page. One of those 3 pairs. They now have names. Not really what I would call exciting names, but they have names. So we now, the one where it's greater than or equal to is the hoe, pairs up with less than. That is called a left-tailed test. Now this test statistic, you're going to, we'll see how to calculate that pretty soon, but it's going to be something that can be calculated, but right here at the very beginning, we're just going to give it to you. So this is the normal curve. Normal curve never seems to go away, does it? The p-value will be the area to the left of that test statistic on the normal curve. So that's what I was talking about. It's not hard to explain how to get it versus what it means, in other words. So pretty straightforward. And let's see. This one, when you have the ho less than or equal to, and the ha of greater than, that means your test statistic is going to be over here on the positive side, and your p-value will be the area under the normal curve to the right of that value. Hey, we know how to get that back from the normal curve stuff, don't we? Because all you got to do is flip it over and look it up. You know, remember that's the flip it over and look it up. That'll do it. Now, this is the trickiest one. So I start out my first couple of examples are usually this one because it's a little tricky. Equal, not equal. Equal, not equal means you've got half the p-value in each end. Because if you think about it, if something is not, you know, we have the last two were less than, greater than. If something is not equal to something, it can be not equal by being smaller than it or not equal by being larger than it. Does that make sense? It can be one or the other can be true. So actually what happens is the p-value, but here's where we got to be careful, is that if you get the p-value, it's to say if you get the left p-value here, which would be right on the chart, that's half of it. So you would have to actually double that answer to get the entire p-value. All right. So we got to be real, and I'll explain that right here in this blurb here. So what I'd like to do for these, because this one, like up here, when it's left tail test, it's going to be a negative test statistic, negative, which is going to be a Z. That's going to be a Z. That's going to be positive. This one, we don't know whether it's going to be positive or negative. But however, they are perfectly symmetric. So they're symmetric. So so whether you get positive or negative when you make the calculation, all you have to do is use the negative, look that up, and then double that one. So if it's negative, leave it negative. If it's positive, make it negative. And then just look it up that way. That's one way that's a quick way to do it. We're going to try this out here. So here's one for a two-tailed test. So the Z, that's your test statistic. For a two-tailed test with Z equals 2.34, we're going to find the p-value. All right. Now I made it positive, but I also sort of shaded over here just to show that it does represent both ends, whether it's negative or positive, it's both ends. But anyway, so what I did is, I'll bring up the normal curve here just to show you. You can even use normal CDF here if you want to on the calculator. If you'd rather do that. Well, let me bring the chart up. Okay. Yeah, we can. So it was 2.34 right there. Negative 2.34. 0096. Okay. Let's go back in here. And, oh. Two times 0096 is 0192 is your p-value. So hang in there. We're close to now deciding, you know, what does that p-value give us in terms of reject or not reject. We're not quite there yet. We're getting close, so I can feel it. Now here's a couple of them where it's asking us to set up the ho and the ha and then determine whether it's left-tailed, right-tailed, or two-tailed. Now, if you get the ho and the ha right, the setup, I probably should, I always keep thinking I should put those problems back up here, but that's okay. Yeah, if you get the ho and the ha right, it shouldn't be that hard for you to look back up here and figure out which one of those three it is. You just have to get the ho and the ha right. That thing's kind of faded there. I hope you can see that that's greater than or equal to. I kind of had to really put a darker line underneath that one. More than, greater than. That's your claim. Greater than, you know, we're going with the three basic forms. Greater than is a ha. It will pair up with a ho of less than or equal to. And I just, it doesn't really matter. You know, I just labeled the claim just to show you that's what it's giving you in the problem. And then once you have this set up, then you just can look and see which is that. You don't have to, if you don't remember, that's okay. And you can see by definition, that's now called, that form is called a right-tailed test. Okay. Let's take a look at the next one. Lucy claims that the mean GPA for all UHD students is 2.8. Is means equal. Equal is always a ho. See, this time, so that's what I'm talking about. The claim can be either the ho or the ha. The claim is just based on the wording in the problem, whether that translates to a symbol that belongs to the ho or the ha. Okay, equal is pretty easy because it automatically pairs up with not equal. Some books, I hate that. I'm glad, I don't know if this one does or not, but I would never use it if it did. Some books like to use equal for all the ho's and then do less than, greater than, or not equal. But I hate that. So I'm not ever going to do that. That's two-tailed. Equal, not equal is always two-tailed. Okay, so let's kind of look at this. We're about done with this section. I'll bring up some homework. What are we saying? You reject the null hypothesis, more likely the alternative is true. Here we go. So that's what I was talking about. Failure to reject the null hypothesis does not prove that it's true. You can never prove the null hypothesis is correct based on sample data. You'd have to have the entire population. But you know, you're not proving the other one either, but you definitely feel all warm and fuzzy if you reject the ho in favor of the ha. You feel a lot better about that ha if you rejected the ho. This is an old book. I don't know if your book. Oh, speaking of book, I completely, the book sections are completely rearranged from my notes. The homework goes with my notes. It's like everything is in there in those book sections, but it's all scrambled around. So it was easier for me to design the homework to match these notes. So I'm not trying, you know, it's because it's, yeah, I didn't like the way they did it. They did 9.3 is called one tails only. Well, I want to include all tails here. I don't want to wait and have one tail be separate. So you'll learn what that is here in a minute. So if you reject the null, you have statistical proof. That's not absolute proof. You have statistical proof. The null hypothesis always refers to the population parameter mu. Even though you're using sample mean, you never will. So you see this as an answer choice in a problem for picking the right ho and ha. I won't write ho and ha on the left, just pretend like it's there. That is no good. It's always based on mu. But you're using the sample mean to come up with your decision, though. But it's not, because sometimes I think there's some homework problems where they have a couple of, I think you pick the right choice. Maybe not ones we'll see this week, maybe they're next week's, but, and I think a couple of the choices use X bar instead of mu. That's never right. It's always got to be the mu because you're using the sample mean to predict the mu. All right, let's bring up some homework. Then we're only going to do about half the next section. I'll tell you how it splits up here when we get to it. Let's see. Oh, where am I here? Let's sign in. All right, let's see what we got here. Everything's open except for stuff I'm not going to open, that we're not going to be using. Okay, preview. Let's see what we got here. Let's take out some of these. Okay. Okay, this is very similar. Oh, I was going to show you how to do that one in the calculator. I'll just do it for this one then. Okay. Okay, Z stat. That's just terminology they're using here. That's just your test statistic Z. It's a two-tailed test. So we'll come over here. Let's see if I can kind of finger draw a normal curve here. But there are two tails, whether it's positive or negative, automatically includes both ends. That's a 4, by the way, as bad as that looks, sorry. Well, chart way, I'll look up negative 1.45, which will be that column right there, 0.735. However, that's not the answer. That represents the same in both ends. I'll do this one in the calculator, but I'm going to add those up without a calculator so you can laugh at me if I miss it. I think it's 1470. Let's see if we get a happy check mark here. Look at that. Woohoo! Okay, calculator, you just got to remember to multiply it by 2. Oh, okay. This next one, I got to show you something here. Maybe I'll redo the notes and post it. Yeah, that won't hurt anything because I'll explain it to you right now, so you'll see it. So it won't affect you any. But let me go back over here. Oh, my calculator! I thought my calculator was already awake. Sorry about that. Because actually, that question I just realized for number 2 is like the first statement in section 9.2. I thought I already had a license for this one. Who cares? All right. So I mean, you can wait and multiply 2 afterwards. I'll go 2 times second distribution, normal CDF, negative infinity to, was it negative 1.45? Oh God, is it 1.35? That'll be different numbers when I go back. Oh, let me look at my scratch page. That's what it'll tell me. 1.45, I got to trust myself, don't I? That's interesting. I wonder if the calculator would have accepted 1471. Hopefully it would. It's usually pretty good about that, isn't it? I mean, the calculator, the MyMathLab. It's usually pretty good about that. So you do what you want. I don't know. I love the technology, but frankly, I could have had that answer. I could have had that answer done in about 10 seconds without doing all that. But if you want to make sure you do it this way, go right ahead. Least I can do is make sure you see it. So. Oh, I mean, a lot of times it's great to use that normal CDF for stuff, but I don't know. You'll have to decide if it's worth it to you or not.
Can you do it again, Professor?
Okay, what part are we not sure about?
I got an error when I tried to do it, so I'm not sure.
Well, I don't know if I can't see what you're doing. I don't know if I'll know.
Yeah, because I'm using I did the same thing you did. I did the 2 times normal CDF, and then I did the negative 1E99, and then I had positive 1.72 instead of instead of the 1.45 you had.
You need, oh, because your numbers were 172?
Yeah, mine was 1.72.
Well, you still should be using negative.
Yeah, so I'm not sure.
Are you using the wrong minus symbol? If you're getting an error, that's what you just said is not going to produce an error. So you did something else wrong.
Okay.
Did you use that minus at the side instead of the minus at the bottom? Because that will always trigger an error.
Yes, I think I did. Let me check.
Because what you just said would have gotten the wrong answer, but it would not have triggered an error.
Okay.
So everybody, I hope you learned a lesson there. When that happens, you probably use the wrong minus sign if it's producing an error. And that's different than getting the wrong numerical answer. That's totally different. But
yeah, I did it. I had an error because of the negative. I did it the first time, but the second time I did it with the other.
Yeah, you probably had one of them right, but the other one was. That's usually what it is. So hopefully that won't cause you any grief now from here on out. Just look for that immediately. So I'm going to see. But anyway, here's another two-tailed one. Now keep in mind, I'm going to go back to that second one for a second. Now this one, once again, you still use it as negative. So still use it even though it's negative, whether it's positive or negative, because it's two-tailed. Do we have one that's not two-tailed? Well, we're going to have them. I mean, we're going to have them when we do the more problems here. They're not always two-tailed. But I wish there would have been a one-tail one in there somewhere. Well, there will be in my note. I mean, you'll see them. And you'll see them. And there's one with about 10 million choices. Without even reading the problem. Can you tell me? Well, there's not even much of a choice here. There's only one answer that can possibly be right here. Because everything else is either using the wrong symbol or it's got it in the wrong order, the ho and the ha. Which one do you think it is? I don't even need to read the question to see which one's the right answer. Shout it out. If you're wrong, that's okay. There's only two of them that have the right symbols. And out of those two, only one of them is in the right order.
So the symbol's going to be equal and then not equal.
I must say symbols. I mean, the variables. In front of the equal. Yeah, well, that's important too. Yeah, the equal and the non. I'm talking about all that alpha, beta, X bar. That's all garbage.
Okay.
That's what I meant first, and then that's what I meant about only two of them even having the right parameter there of mu. The rest of them all are just weird stuff. Yeah, so you narrow it down to two of mu, then you got to figure out which one's in the right ho and ha position. You got it?
Maybe I?
Maybe I? Alpha, we're not, alpha is not there ever. It's because.
Oh, that's right. I'm sorry.
Yeah, that's okay. It's because the alpha is not right. Everything is mu.
So then it's H.
H is one of the two possible correct answers. I mean, well, possible. They're not both correct. You have the right symbols now, very good. It's either H or J. But look at the problem with H.
Oh, because the ho should be the.
There you go. There you go. Yeah, so right off the bat, it's either H or J. Nothing else is even close without even reading the question. And then right. So you narrow it down to those. You had, when you picked I, you had the right equal, not equal there, but
yeah,
that's because that alpha is just, that's what I'm talking about. There's just a bunch of nonsense characters in a bunch of these answers, Same reason that E isn't right. That's not right. F's not right. It's definitely J. Ta-da! All right. Yeah, let's go back here. We'll look at the type 1 and type 2. Yeah, these are asking these questions again. Yeah, we got to do some p-values where it's not two-tailed. Anyway, this question, actually, that's what I was talking about, is the way to answer this question actually requires the first thing we're going to learn here in the next section. Right there. So it's almost tempting for me to, I like that problem. Either I should have put it in the 9.2 homework, too late now, but, or I can just add this blurb in at the end of 9.1. It doesn't hurt it to be in there twice. I could put this part in back in the 9.1 notes. So this tells you if you have the p-value, and then of course you got to be given the alpha, whether or not you reject the hoe or fail to reject the hoe. This is the rule. That's pretty straightforward. Now it says less than or equal to. Now I usually just say less than. It's really unlikely that's going to be equal. If your p-value less than or equal to your alpha, reject the hoe. P-value greater than alpha, you fail to reject that hoe. So now we can answer that question. So I could probably recopy the notes. That'd probably be the easiest thing to do now and repost them. But that way nobody that hasn't seen it yet will know the difference. Other than if they listen to this video, or I don't know, maybe I'll wait. I'm recording this one, but maybe I'll record Mondays and use that one instead. We'll see. I had where's my previews up here? Let's see. The p-value is 0. So I always do it like this. Because, make sure I get it in the right order. I always put the p-value first, like this, and then alpha second. Because you got to be careful when you write numbers with inequalities like this to make it match what I have written in words there, because this isn't a p-value question, but let me come down here and show you this. I mean, like if I have those two inequalities, are they both correct? Is one correct and one wrong? What do you think?
They look both correct.
That's it. Yeah. You're trying to find some trick there, aren't you? But
yeah.
No, they're both. So that's why it's important, because even though you could write it the other way, but you would have to change your arrows the other way to make sure you pick the right answer. So it's always better to look at the p-value on the left and the alpha on the right, so it matches what I put in that definition. So yeah, see, it's true. Those are both right. So in other words, when I say the p-value less than alpha, I like to say it that way but technically, mathematically, saying that alpha greater than p-value would also be correct. That just makes it more confusing to do it both ways. It's confusing, but this will be a lot better. So let me look at this. See, you thought there was a trick there, but you knew in your instinct that, wait a minute, those are both right. So here's the p-value 0.335, and the level of significance 0.08. So 0.33508. Oh, sorry, it looks like crap. That's a pretty terrible looking. Oh, good grief. I probably could draw it better. I got to find the stylus that goes with this stupid thing. My other laptop is, I'll come check the chat here in a minute. All right, what's my, okay. My other tablet I like, my really old tablet, somehow something, Windows 10 fried or something. I mean, they're going to have to probably buy a new one in Windows 10, and hopefully I can get it working, but this is sufficient enough. This will work. Okay, let's forget less than or equal to. Let's just go with less than or greater than, because I'm not going to have one where, it's equal. But so what inequality symbol would go there? Less than or greater than? It's tricky with zeros in front, isn't it? You can do it. What is it? Shout it out. You got a 1 in 2 chance of being right. Oh, let me see. Maybe somebody typed it in the chat. Sorry. Okay. Which one is it? Less than or greater than? I'll show you a little trick afterwards. Someone shout it out for me.
Less than.
There you go. Figure better say something because he's not going to give up on it here. So you're right. That's correct. Now it's less than. So by definition, if it's less than, which we're just learning this for the first time, that means the ho's got to go. Since the p-value is less than alpha, yeah, there's two of them that say p-value less than alpha, but only D is the one that's the right conclusion. You reject that ho. Bye, ho. Beautiful. Now, it can be a little tricky with these zeros. Let me show you a little trick back over here. There's a couple little tricks for numbers I'll show you, but here's one that I've kind of shown people. Like, this one's not too bad, but what if we had, I think that's going to come up in the next section anyway, so maybe I should just wait. So yeah, I'll just wait to the next section right after break. You know, that's, yeah, we'll see this come up. But anyway, the trick is going to be if you move these over by 4 decimal places and make them whole numbers, then you can tell easier. 335, and that becomes 800 if you move it over 4. You got to do the same on both sides. Then it's a whole lot easy to see now, isn't it? Oh, 335 is less than 800. That's tremendous. All right, well, I'm not going to do every one of them in here. I don't want to spoil all your fun, but there's no, I'll leave that one for you. Let's just look at one of these. Here's the legal system question. I'll tell you what, I'll leave that one there, you know, so you can try to use the thing in my notes. Defendant is presumed innocent, null and alternative hypothesis. Same kind of question, isn't it? That's all right. I'll just do this one. Innocent, guilty. Final check. They're not playing around here, are they? Hey, come on now. What happened? Did I misread that? Oh, I didn't read the, oh, come on. Oh, okay, we learned something here. I didn't bother reading the question very carefully. This question's stupid anyway. I mean, you know, it says you're considered to be presumed guilty. That's not right, but I mean, it is in this problem, but no way if I put this kind of question on a test would I use this kind of idea. So you see why I butchered it up? You don't have to speak if you don't want to, but why I got it wrong? Because I didn't bother to really even read that, because I went with the normal human, you know, response there. Good Lord. So this, it's the opposite of what we did earlier. So a type 1 error would be rejecting the ho when the ho is true. So you found them innocent when they were really guilty, which is not what it is normally. So that's a type 1. Type 1 is going to be not convicting a guilty person. So it's either A and C, but we got to look at what type 2 is. Type 2 is failing to reject the ho when the ho is false. So the ho was wrong and we didn't reject the ho. So type 2 error would be not convicting an innocent person. Okay, this one's really, really stupid. Okay, I just missed it. What did I misread it? Because it just doesn't make any sense. Because it's just illogical. All right, just take a picture of this answer so you can get it right. Because I really don't care. Because I guarantee if I put this thing on the test, it's going to be the normal way that you're presumed innocent. Great. Yeah, this is probably, let's see. Yeah, see this one before it, try this. This is how it's supposed to be. You're presumed innocent. Let's try one more of these type 1 errors and we'll move on. Maybe this one. Let's see. Considering a null hypothesis, an unapproved drug is unsafe, and an alternative hypothesis that a new unapproved drug is safe. Type 1 error. You're rejecting the drug being unsafe in favor of being safe. Incorrectly approving an unsafe drug. That to me, that narrows it down to A or C. And this is where I messed up last time. Type 2 is failing to reject the hoe when the hoe is false. So you did not reject that it was unsafe when in fact it was really safe. I'm going to go with A. Yay. Yay for A. Oh, more to this. What type of error are the consumer groups trying to avoid? You know, this kind of hypothesis is actually kind of interesting, you know, especially if we come to a point where there's going to be a COVID vaccination at some point. You know, that's kind of an interesting idea, isn't it? Might prevent COVID, but it might make you grow a big unicorn horn in your forehead or something. I don't know, but hopefully that might be kind of cool though, right? Let's see. Which one, you're trying to say which one is worse. Let's kind of look at these. And you can almost tell without thinking too hard that the incorrectly approving an unsafe drug is by far worse, isn't it, than incorrectly failing to approve a safe drug. I got to go with type 1 error. It's got to be, but there's two ways to do it because they think too many unsafe drugs are approved. I want to go with D. Nice work. Oh, let's see. Let's move on here. Yes. Oh, there's more to this? Oh, good grief. I don't see the last. Oh, there it is. Industry lobbyists are trying to. Oh, what are they trying to do? The industry are going to want to. Okay, they're going to probably think C because they don't want it to be so hard to get safe drugs, even though that's still not as bad as an unsafe drug. Okay. Good Lord, is this question ever going to end? How could it be possible to lower? Oh, I haven't talked about beta really, so I hope that's not the right answer. Well, you know what? I'm not totally sure. I think I know what it is. But anytime in statistics that if you want more accuracy, increase the sample size. I mean, that's always better. Please let it be the right answer here. That's kind of how it all works. You know, the larger the sample size, the better your results. Okay, so it wasn't, okay, that wasn't too bad then. So, all right, so I'm going to stop there for this. Won't take us to, we're going to go, here's what's going to happen.
Can you go back to number 1?
Okay, give me a second here.
Okay.
We're going to do this again. We're going to go through here to right there, we're going to stop right before rejection regions and critical values. And then we're going to do, that's what we're going to do, this part of it. And then look at a couple of homeworks, and that'll be the end of this week. So, yeah, I'll real quick. I mean, if not, we're about to go on break here in a second. So how long a break do you want here? 10 minutes?
That sounds good.
Yeah. I'm going to take my temperature. I think that ibuprofen might be working. I feel a lot more energetic now than, see if my 99.8 is down to something a little bit better now. That might have helped me. I don't feel so warm and toasty now. I don't have that warm and fuzzy feeling. All right, so we're going to do some 9 point. 9 point. I didn't close that out already, did I? Maybe I did. Well, I mean, if I close it out, it's going to be different numbers here or whatever. But all right, we'll say we're on break, but I'll answer this question. So if anybody's listening, they can listen. So what do you want? Whoever wanted to ask me about this one, what do you want to ask me? Newt?
Oh, I just wanted to see how you did that.
I would do it with a chart, I mean, myself, but if it's positive or negative, look it up as a negative, like right here. So what was that, 1.80? I'd look at negative 1.80. You use a normal CDF, but this would be a lot faster. There's negative 1.80 right there, 0.359. I would take 0.359. I'd have 0.718. And that's only because it's two-tailed. Now we'll see some left and right-tailed ones coming up here. You don't multiply it by 2. You only multiply it by 2 when it's two-tailed. So we're going to see some left and right tails come up here in a minute. So there it was. So you could do the normal CDF, you know, whatever. I'm sure it'll be close enough.
Okay, thank you.
You're very welcome. I'll stick that in there real quick. Well, heck, I can just do this. I can just bring it back up to where this command was, and I'll put negative 1.80 right in there. Oh, well, I'll put it in the right spot here. Like I said, I think it'll be okay, even if it's just off by the last decimal place. I think it would have accepted 0.719. I'm sure it would have. Because there's no way with me to check, I guess. But I'll go ahead and bring the next bit of notes up here. So they'll be, so we kind of already just talked about, there's another two-tail. We'll see another example of that. But now we'll do some one-tails coming up here in a minute. All right, I'll be back in just a few minutes, about 5 minutes or so. All right, I'm back. Oh, just taking my temperature, only little crappy digital thermometers. I wish I had an old mercury thermometer. Those were the best, but they had to kind of get rid of them. Get me a better one. It keeps showing. Felt like I cooled down a little bit, but it's still showing 99.7. That might be normal on that crappy little thing. I don't know. So, anyway. Back in action just for a little bit more fun here today. And let's see what we got here. Okay, so we just talked about this. There we go, right? So, and we're going to be using that again now. And it's another two-tail. I know everything seems to be two-tail, but we're going to rectify that here in a minute. Maybe I'll just make up a one-tail, but if not, we'll do one. It's a one-tail for sure. Oh, let's see. Test statistic is negative 1.72, so it's already negative. You don't have to make it negative, so you can look it up on the chart. I'll show you another way you can do it here in a few minutes. But for now, here I did, well, that's the normal CDF. I'm going to get rid of that and put it in there the more modern looking way, because I don't use 100 anymore. I use the negative 1e to the 99. So I can put that back in here, change it to 1.72. Uh, 0854. So there we go. So if you look up on the chart, you get 0.427, and then just multiply that times 2. Now let's look at this. Suppose you determine whether or not to reject the hoe given a certain level of significance. Now this one's 0.05. So notice I always write the p-value first and the alpha second. So my arrows, match this right here. That's kind of like I was showing you the 2 less than 3 and the 3 greater than 2 thing. But you want to put the p-value on the left and the alpha on the right. 0.0854 is greater than 0.05. And therefore we'd fail to reject. Now suppose alpha was changed to 0.10. Then 0.0854 would be less than 0.10. We reject the hoe. Now this would not, a statistician wouldn't like this result, because they want it to be kind of clearly reject. Either that they want the p-value to be really, really, really small, or if it's not going to reject, be a little bit larger to where it's no question either way. That's just because that's reject or not reject literally just on the choice of alpha. So that's a little frustrating for a statistician to have to do. But once again, let me see. I thought I had a, that's a good one right there. But if you're comparing these numbers and you're not sure, once again, you could just take them and multiply them by 1,000, 10,000. Because there's 4 decimals. And that really comes in handy when you have, I'll show you here in a minute. 500. Then you can tell that 854 is greater than 500. Another way you can do it is you can choose which one you think is the greater number. If you think, and want to verify, you think that 0.854 is the greater number, that means when you subtract the other number, it's going to be positive. If you're wrong, it just means the answer would be negative. So you could also do this. Well, I think 0.854 is positive. I mean, is bigger. So I'm going to go like this. And it's positive. Therefore, it was bigger. Now, let's say if I thought 0.854 was also greater than 0.10 and did that. Now look, it's negative. Well, it's no big deal. It just means I made the wrong choice, and then we know the other one's larger. You didn't mess anything up. Because sometimes it can get kind of tricky. Let's say if you have, let's see, let me come over to my scratch page here and let's see. Let me go 0, 0, I don't know, 7, and I'll put 0, 5 over here. Interesting. 7 is greater than 5, but the extra 0 in front makes it a smaller number. So it would go this way. But if you did the thing multiplying it by 10,000, here's what you'd get. You'd get 70 on this side, and you'd get 500 over here. You multiply both numbers by 10,000. Now you can clearly see this is true, right? Ta-da! All right, let's keep playing along here. Now, so most people confuse these rules. We should have them written down. You shouldn't confuse them. No, you don't have to memorize them. But it's saying here that this is kind of acting like if somebody wasn't, had to memorize it or whatever and had to learn it without. I like this expression. If the P is low, the whole must go. I like that. Kind of has a nice catchphrase to it there, doesn't it? The P value is low, then the whole must go. All right, there we go. That means we're rejecting the whole. Okay, here we go. Here comes some number crunching now. You ready for a little bit of this? Here is your test statistic, calculated from sample data. It's a Z, and it'll be a T in the next section. It's X bar minus mu naught, mu 0. The mu 0, once again, that's whatever number you're testing against in the problem, whatever, the ho or ha is being tested against. Divided by standard deviation over the square root of n. So we've seen that standard deviation divided by the square root of n before, earlier in this unit, in this exam 3 unit. 2 ways to do this: p-values and using rejection regions and critical values. Now that's why I split this up, because when we do the t-test, we're not going to use p-values anyway, because people would have to have technology. You can do p-values without having the technology for the z, but not for the t. So we're going to do everything rejection regions. So I'm going to wait. That's what next week's conclusion to the course will be. Will be the second part of this, and then taking it into the next section, using it for the t distribution. All right. So we're going to do a little bit of p-values today. And we'll, now the homework's going to have things kind of mixed, so I'm only going to be able to do parts of problems. So what I'll probably do is just pick, ones where it's already got the answers selected, so then I can just show you which ones we're going to do, because I might not be able to. It depends on the order, because I think there's problems in here where it asks you to do it by both methods. Well, we're not going to see both methods today, so we're only going to see p-values. So I have to make sure I just select those. I might just pick the ones that already are marked with the answer and then just show you how to get it. So keep that in mind if you're actually trying some of this homework. You might want to just wait. You might just want to focus on 9.1 and possibly wait till after next Wednesday to start 9.2 and 9.3. I don't know, because I wouldn't want you to get confused. And it's too bad those multi-part problems don't allow you to kind of jump around a bit. Okay. So here we go. So we're going to do these in a, let's see. One of your distributors reports an average of 150 sales per day for the distributorship. Of pretty much means equal. Okay. So you're the one testing this, so this is actually your claim. You suspect that this average is not correct. So you're claiming not equal 150. That's your claim. And then not equal automatically pairs up with a ho of equal. So there's where the ho and ha come from. Not correct, not equal. Actually, together they make the ho and the ha. So you randomly select 35 days and determine the number of sales each day. Sample mean is 143 daily sales with a population standard deviation of 15 sales. Given a level of significance of 0.01, so that's your alpha, is there enough evidence to doubt the distributor's reported average? All right, N is 35. Alpha's 143, means 143. Standard deviation's 15. Alpha's 0.01. This is a two-tailed test. So we'll have to, if you do it this way, but I'm going to show you a fancy new way to do it here in the calculator. And so to calculate here's the formula for the test statistic. So here's how we get that Z. All the other times, we've just been given the Z because, we didn't have this information. It's 143, the sample mean, minus 150, what's called the term for that is hypothesized mean. You don't have to know that as a term, but it's whatever this number is we're testing right there. It goes second. Divided by 15 over the square root of 35. And I got negative 2.76. Now, if you use a chart, we look up negative 2.76. If you're doing it this way, it's going to be the seventh column right there, 0029. Yeah, 00, there it is. 0029. And we double that because it's two-tailed. We get 0058. And we're comparing that to the alpha, which has to be given. We're comparing that to 0.1. Now, can you tell that the less than is correct here? So like that example I showed you on my scratch page a minute ago. Yeah, you got a 5 there, which is bigger than 1, but you also have that extra 0 in front of it, which makes it a smaller number. If you do the thing I said about multiplying both of them by 10,000, you'll end up with 58 being less than 100. You might not need to do that if you're okay just by looking at that and see, but it's tricky with the zeros and these decimal numbers to see which one is. So the rule is if the p-value is less than alpha, we reject that ho. Therefore, there is sufficient evidence, once again, not absolute proof, but we strongly feel we support the claim that the mean sales per day is not equal to 150. We think they are wrong. You're wrong. All right. So you ready to see this now in the calculator? I know you are. Stat, test, Z test. Okay. Z test and T test are going to be for hypothesis test. Number 7 and number 8 that we've already used are for confidence intervals. So you see how the names of those intervals for confidence intervals, test for test. I'm not trying to talk to you like your children or anything like that, but you wouldn't you'd be amazed how many times they pull up the wrong thing and they go, this doesn't look right. How do I get my numbers in here? None of this looks right. It's because they picked the not whether it's a Z or T, they picked they picked a Z test to do a confidence interval or something like that, so they can't make any sense of what to do there or whatever. So I think it's, You make yourself a note, have that in front of you. So it's test with, so I think the names work pretty good too. Test for hypothesis test, an interval for confidence interval. But I'll get that asked, and because the inputs don't look right to them, and then they realize, oh, that's what it was. I was using the wrong thing there. So we're going to use 1 and 2. No, we're not using number 2 today. We will next week, the final week, and the final lecture. All right, so let me walk through this real carefully. Stats, okay, kind of same thing. That starts out the same as a confidence interval. The hypothesized mean that we're testing against is 150. I forgot the standard deviation. 15. $143. I believe that was 35. I'll double check. Yeah. Now here's the key. To get the p-value right, you've got to do this part right. They list, because there's no need for them to list the ho's and the ha's here to make this technology work. So they just have the 3 possible ha's listed here, which are not equal, less than, greater than, because you don't need all of them to do the, it could have given us the ho's, but it didn't, gave us the ha's. So our ha, alternative hypothesis, I'll just show you, is not equal. So we have to pick. Now it's going to give you the right test statistic no matter which one you pick. But if you're looking for the p-value, it will not give you the right p-value without picking the right thing here. So I'm going to hit enter right here. I have no idea what the color business means. I just ignore that. Then I hit calculate. So let's take a look at everything that's in there. I think I've got it on the next page of the notes. I just hadn't scrolled down yet. But it's on your test statistic. Now you see that the p-value here is already doubled. You don't double that answer. It's already calculated it for you. There it is, 0.0058. Isn't that fun? All right. Oh, you're dying to see more here. So here it is. So I'm just mentioning these are the ha's. That looks like it's an 83 instead of an whatever, but they'll work pretty much the same for this, 83, 84. Nothing too distinct here. Now, there's one thing, I didn't put this in the notes, but I'll show you this. This should work. I thought about this last semester and never came up. Now, you got to be careful if you do this. You could possibly use that z-test, if you're careful, to do this thing right here. But let me see, because you have to base it on the z here. Let me see if this will work. If I'm wrong, then forget I ever said it. We'll just try it and see what happens. I don't know if I'd even bother with this, but I still want to show you this anyway. You don't have to really care. So I'm going to put in I'm going to put in 0 here. Yeah, this is already going to be worse than I thought. And then, okay, I might not know what I'm doing here. So negative. I'm trying to get that z to be 1.72 with a mean and then standard deviation of 1 here. This might not work. N needs to be 1 also. I think this might work. Okay, this is not equal. I think it got it, didn't it? Hey, okay, I was right. I don't know if you think that's worth your trouble or not, but let me go back and let you look at that so you can take a picture of that, and if you wanted to, or so that's just, if you're trying to get that p-value where you're given the z-value. In other words, you don't have to calculate. If you have to calculate the z-value, just do the z-test, like normal. Because I needed that number to be 1.72, so that negative 1.72, because that way negative 1.72 minus 0 makes negative 1.72, divided by 1 over the square root of 1. So that's just dividing by 1, so that kept it negative 1.72, and there it was. So I don't know. I don't know if that's worth your time or not. You'll have to decide. Because if I thought it was tremendous, I would say, ooh, this is wonderful. Make sure you do this. Let's try another problem here. A couple more of these, and we'll go to the homework. Look at a couple of those, whatever we can do, parts of it. All right, sprinkler systems. Fire protection claims the average activating temperature is at least 135. You select a sample of 32 systems and find the mean activation temperature to be 133. That's not too bad. The last thing you'd want is for this thing to be activated at about 78 degrees. That'd be no good, would it? At least if it's a little bit less than that, it's not the end of the world. I wouldn't be that upset. If that room got to 133 and it came on, that would not hurt my feelings. All right, select 32. The activation temperature was 133 with a population standard deviation of 3.3. Level of significance of 0.10. Do you have enough evidence to reject the manufacturer's claim? Now, let's set up the ho and the ha. And I can skip this part right here now that I've shown it to you, because it seemed like, whether I do this class or Monday class, it pretty much seems like everybody that attends these things is pretty much using the calculator. But I was showing you that, before I showed you the z-test. Now that I've shown you the z-test. But let's focus on the ho and the ha setup here, because at least means greater than or equal to. Since it has an equal, it has to be a ho. And then that greater than or equal to by definition pairs up with less than. So remember, there's only 3 accurate pairings here. And now we've learned that once again, I'll expect you to know that. Oh, I put it right over there. We learned that earlier too. That's now called a left-tailed test. Okay, now I will mention this before I use the calculator, because finally we're doing one that's not two-tailed. If somebody's doing this, so if you calculate the z, we don't double this p-value. It's a left-tailed test, so it's only that area. Because we do so many of those two-tails, because that's the trickiest one. You only double it whenever it's the two-tailed. Otherwise, now when it's a right-tailed test, we'll flip it over and make it negative and look it up. But so this is not 0,003 times 2. It's just 0,003. Now, let's put everything in there. Are we ready? That's the spirit. Stats, mu0. We're testing 135. I want to say 3.3. Uh, 133 is a sample mean, and it's 32. Now, very, very important here. Oh, this is probably kicking me out of the homework, isn't it? Probably have to reboot and get back in there again. Well, I'll figure that out in a minute. Very, very important to get the right p-value. It's all based on the ha. The ha is less than. And if you're not sure, I mean, he's just making that up. I'm not going to do it, but I won't, be offended if you don't take everything I say for granted. My point is, you try this calculation for all three of those, and I promise you it's going to give you three different p-values. You can do it and go, dang, he was right. Hate it when he's right. But it's got to be less than, because our ha is less than. Because that's the key. The rest of that's easy, entering the numbers, but that's the key step right there. Now, this test statistical, let me clarify, that negative 3.43, that's going to be the same no matter which of those arrows you pick. P-value, that's just scientific notation. You move the decimal 4 places over to the left, so you would have 0.0003, just like I got off the chart. So that's just as correct. And since 0.0003 is less than 0.10, we reject the claim that the activating temp is at least 135 degrees. That doesn't necessarily mean I would refuse to use their product. Like I said, if it's coming on even around 133, that's probably good enough. Because if you got something 133, 135, something's probably on fire. It doesn't really matter. So at that point, anyway, so we just rejected that hoe. Beautiful. In Texas, a random sample of 85 8th grade students has a mean score of 282 with a population standard deviation of 35 on some national math assessment test. This state administrator declares that the state's 8th graders for this exam is more than 275. So maybe he or she is going to get a new swimming pool or something if they do well as a bonus. I don't know. They're going to get a bonus, so they want to proclaim it. No, I don't know, but I'm just joking. But if they reach that target, but I mean, I can't imagine there's enough money around in education to be giving people swimming pools. If not, we're definitely wasting money. Given a level significance of 0.04, is there enough evidence to support the administrator's claim? Now, let's look at the ho and the ha, and this wording's a little bit different. We haven't seen this yet. More than 275. So they're claiming more than 275. So that's your ha. Your ho is less than or equal to. Now, one thing about this whole thing that goes way back to earlier about the fail or reject, we're never really supporting a ho. However, to support this ha, which we can certainly do, supporting the ha means rejection of the ho. So for this to be answered yes, that we support this claim, it's going to be because we rejected the ho. If we did not reject the ho, we will not support their claim. So in this case, reject is going to mean support. Okay, blah, blah, blah. Let's see. Let's put it in the calculator. That's the fun stuff. Z-test. And the was 275, and then 282 is the actual sample mean. Let me jump over just for a second to get to that, since I remember that. And I'm going to go back and get the standard deviation and the sample size. Standard deviation is 35 and 85 students. Now, which one of these is it going to be? Very important. Notice that the alternative is greater than. So we're going to pick greater than. Very important to get the p-value right. And I screwed it up. Where did I screw it up? Well, I would have known I screwed it up, but only because I've done this problem before. All right. Oh, N was 85, wasn't it? Let's see. Yes, 85. Oh, and then there we go. 0326. I got 0329 using the chart. Once again, that's going to happen. Won't mess you up on a test or anything. Hopefully, the homework is, but it seems to be geared where it works for calculator or. Let's see. So you're okay now. Anyway. So here's what it looks like visually, just to kind of show you this, see the greater than. So if you were doing this using the chart, it's not double. Once again, we don't double this one. Only the left-tailed, only the two-tailed gets doubled. So this is a right-tailed, so all I would do is just look up negative 1.84 on the chart, and that's how I got that number right there. Of course, we just did it in the calculator, which is fine. Anyway, 0329, 0326, whatever you use. Yeah, certainly got to make sure that these are not. That would be terrible if these overlapped and made it reject and not reject, depending on which one of these numbers, but I don't think that's going to happen. But less than 0.04, it's a little bit under. It's not way under it, but technically it's a little under. P-value less than alpha. We reject the whole. Rejecting the whole, like I said earlier, that means we support the claim that the mean test score is greater than 275. We agree with it. It's not absolute proof, but you can sort of say it's statistical proof or statistical evidence. Strong statistical evidence. But it's even stronger. Let's say if this p-value would have been even smaller, like 0.000 something, then it's really strong. Oh, I just put zeros here. What does this one say? $675 daily mean revenue, 625. If you were to test, yeah, this one you don't have to really calculate anything. So let's see if we can get a ho. I'll just kind of get a ho and a ha down there real quick. That's 625 is the sample mean. So we're testing, you were to test the null hypothesis was, of course, is just the past tense of is. So, if that's still an equal. Earlier I mentioned is and of. I don't know if you'll ever have one that's a was on a test, but speaking past tense, but I would prefer to use is. So here's our ho-ha. Ho-ha. There, let's see, and decide not to reject. Oh, what were the claiming? Oh, that was actually the claim then. That was 675. Okay. So I want to identify that just to see if that helps us any right there. The claim seems to be the ho. just to help us think through this a little bit. All right. We did not reject. Okay. Once again, not rejecting the hoe doesn't mean we love the hoe. It just means there's not enough evidence to say it's wrong. That's why C is the correct answer. There's not enough evidence to conclude that it's not 675, meaning there's not enough evidence to agree with the ha because we didn't reject. I know it looks like D would be the right answer, but it is not. That's not evidence to claim that the hoe is true. We just don't have the evidence to claim we don't have the evidence to say that the hoe is wrong. It's pretty tricky, isn't it? Makes you think about this stuff, doesn't it? All right, we're getting close here, about ready to jump in the homework in a second. I think about one more. Well, I'll leave it there for a second because I got to go back to it. Oh, okay, we've talked about this. Yeah, this will be it. Here's one where it gives you the p-value, and we're just testing it for rejection at 3 different levels. 0.10, 0.05, 0.01. So there's several ways you can do this. You can do it by putting let me copy this and paste it so I don't have to keep writing it. Because I'm going to do, oh, that didn't help. Did it? I should have moved the first one after I copied it. Yeah. I'll probably not put it way down here somewhere where I don't need it. Yeah, so this will be the beginning of next week's show here. So we're going to put this, these 3, and then I'm going to put, and we'll decide what inequalities go here. And I'm going to let you join in. Are you excited? Okay, all I'm going to ask you first here is, and then we'll go right to the answer from there. So we're all 3 of these lines, 0.036 with 0.10. Tell me if that's a less than or greater than. That's all I'm asking. It's good practice for you too. Even if you're wrong, it's still good practice.
So you mean you're asking like if the numbers on the left side they're smaller than the ones on the right side?
We're doing it one by one. So okay, so just do it one by one. They're not all. That's the whole point here.
Oh, okay.
Yeah. Let's just do it one at a time and not do it by group. So you're saying the first one's less than? You are correct. That is definitely less than. You're on the right track. How about the next one?
Less than 2.
There you go. How about the last one?
Yeah.
Somebody said greater? That is correct. So the rule is less than means reject. Greater than means fail to reject. And they're answering this in terms of yes, yes, no. So I'm going to say yes, yes, no. It's terms of reject. So that's why it's answer D. Yes, yes, no. You reject at 0.10. You reject at 0.05, but you do not reject at 0.01. See, there you go. I know you could do it. So it's sometimes people like this, might make it way more complicated than it needed to be. That's all I wanted to know. You're just comparing them individually to each of those 3 specific alphas. They weren't all one lump sum answer. They were just different ones. So reject yes, reject no. Isn't that beautiful? Let's jump over to the homework, do a couple of these, and we'll call it a week. Yeah. Went a little longer today than I thought, but I think it's because I wanted to kind of, since I knew I had the time, I went extra slow. So I thought that might help a little bit from a learning standpoint. I mean, I could have been done by 7 o'clock if I really would have sped up, but what good does that do? So we'll do a couple of homeworks and we're finished. And like I said, we'll finish this section next week, the last section. And then, here in the next couple, 3 days, once I pick what due date it's going to be, I'm going to reopen all the homework pretty soon, like in the next couple days, maybe even today, I don't know. We're going to open them all up. I just got to look at the schedule. And I got to look and see, because usually I let it go a little bit even past finals week. That's okay. I just got to make sure I cut it off. That gives me enough time to submit the grades. That's all I got to make sure I do. I don't mind giving you more time. I just got to make sure the grades get submitted properly on time. Anyway, so that'll be exciting news. I'm sure everybody kept saying, yeah, because these 11-8, okay, so those ended already. Well, you have new ones open, obviously, so that's the important thing is the newer ones anyway. So, but then whatever, I'll set the same date for all of them, beginning to end, and well, hopefully maybe I'll wait a couple days. So hopefully people will still focus on this a little bit, Or I guess it doesn't matter if you still focus on this. You can go back and do all right, let's see if it'll let me in there. Did it log me out earlier? Oh, it's in there. Oh yeah, this was in I guess I should have eliminated that problem in the last section. Well, that's okay. We talked about it and we know how to do it now. So yeah, I should have deleted that one or moved it over here. But here's that same one that was in 9.1, not the same numbers, but p-values 0.264, level significance 0.04. Yeah, I can't change it now on that other one because if anybody's even done one of the homework problems, that means it's already, I can't edit it, but that's all right. P-value is less than alpha? I like reject. And okay, I'll skip over that right now. Yeah, lower tail means left-tailed. So really, don't double this one. If it's one tail, lower tail, that lower tail means left, upper means right. That's just the way this book terminology works. Negative 2.07. I'm just going to look up negative 2.07 right off the chart. I'm going to skip all the technology business here. I'm usually a big fan of the technology, but let's get this done a little quicker. 0.192. I could do. Let me look around a little bit. Let's see. This could be a good one. But this is one of the ones that probably I'll come back to one of those where I have to kind of highlight it because, yeah, I've been amazed I haven't coughed more this class. I was coughing hard earlier, so it worked out well. Now I'll probably start as soon as we're done. It's okay. Get out of this before it comes back. Yeah, this is what I was talking about earlier. Like some of this, we critical Z-score, we'll learn that next week. So we can't, but we see I could do B, but the problem is I can't do A, but I could do B and get the p-value because we know how to do that. So we can do part of that problem right now without doing the whole thing. But let me come back and do one of these two. They were very similar. Oh, no, this one. No, not this one. Oh, yeah, well, same thing. We're just going to have to skip over that. So I'll just leave the answers here. Now I'll answer the question on the reject based on this p-value. The reason why they didn't do it because they already used the other method to come up. That's one thing you're going to learn too. The other method we're going to learn, I mean, no matter which method it is, they either both reject or they both don't reject. If you've got reject one way and fail to reject the other, that means you did something wrong. So in other words, there's no question. So, but anyway, so let's just tackle this one real quick, and actually the part of it we can do. What conclusions should be drawn? We can't do B yet. We can get the test statistic from the calculator though. So like I said, next week we'll be able to do that. So there's a right tail test. Let's see. Stat. mu0 is 46. Oh gosh, I shouldn't have talked about the coughing. Now I jinxed myself. Oh, I was doing so well. 11. Oh. And then now this is important right here. You see the H1 or the HA, same thing. It's greater than. I drink something, I don't think that's going to help. It's greater than. And so we got to pick greater than. The ha is greater than. So I can pick greater than here. That's already greater than, but there it is. And then let's see the test statistic. Rounded to 2 decimal places. There's 1.11. Critical Z score is going to be something off of a chart. But anyway, let's jump ahead, and then we'll get this do not reject answer, but we'll get it from the p-value. So you see the p-value, there it is, 0.134. Alpha's 0.10. So 0.134 is greater than 0.10. So we do not reject. And notice that do not reject was already there from the other method, which I'll show you next week. So like I said, it was going to lead to the same answer. So, but they'd already answered it. Do not reject. There was no point in answering it again. So you see, we're just doing everything except for that part we haven't learned. But it's clearly, we do not reject the ho here. All right, let's try another one. Let's kind of jump around here a little bit. Well, I like the ones where we got to predict. Okay, I like these. Yeah, well, several of these are good. They're all kind of the same thing. Like I said, the only thing is we just can't do we just can't do the critical. So I'll save, obviously I'll do one more of these, and I'll save these because then next week after I finish the rest of 9.2, we can attack an entire problem on this. But let me just do another partial. But I want to do one of these where I'm going to undo this. Oh, the problem is though, I better take a picture of the numbers though, because it's going to change when I want it, or maybe not. No, okay, I think it's asking us to pick a ho and ha. I like that. Student, our university advertises that its class sizes is 32 or less. A student concerned budget cuts have led to increased class sizes and would like to test this claim. Random sample 43 class selected. Average class size was 34.5. Standard deviation 9. Okay, let's get the hole in the ha here. 32 or less. I do believe that's going to be less than or equal to. Less than or equal to, because it has an equal, is a ho. It pairs up with greater than. $32. Let's see if I got it right. Woohoo! Now, if I bring up the completed problem, though, it shouldn't change the number, should it? Ah, it did. That's all right. That's okay. We can just do it with new numbers here. That's fine. That's okay. Because I haven't done anything in the calculator anyway. So you see it's the same thing here. Less than or equal to, greater than. So that works. So let's go to the calculator and get the test statistic and the p-value. The mu zero now is 29 because the number's changed. Average class size was 31.7. I wonder if UHD makes any claims like that about their class sizes. I mean, they're obviously smaller than other places, but I've never heard if they actually make a numerical claim or not. $39. That's one of the benefits about UHD is you're not in a room with 200 people. Let's see, is that, okay, so this is the alternative hypothesis is greater than. Okay, once again, it's greater than again. .11 rounded to 2 decimal places. Okay, there it is right there, 2.11. Now the p-value rounded to 3 decimal places is 0.18. There it is. Now we'll answer the reject question based on that, even though you'll be able to answer it. Well, actually, when you do this in the calculator, even though you'll have the p-value there, so you can make your, well, actually it's asking you by the critical value, so you'll have to come up with that. At least you'll know whether or not the reject or not reject is, you can use the p-value. 0.018 is less than 0.10. So that's clearly reject. P-value less than alpha, we reject. Isn't that tremendous? All right, let's see. I don't know. We about had enough for today. What do you think? Because we're going to see these again next week. So how do you feel?
So next week we'll learn how to
do that one part.
The critical Z
right.
score.
And then you'll see everything else done in the calculator again too, you know. So but I can do one more. I don't care. I mean, but like I said, yeah, you'll see that part next week. Absolutely. So I know that kind of limits you now what you can do on the homework because, well, I mean, unless you just wanted to read ahead, you know, in other words, but I'll actually show it next week. One thing I miss about this the only thing teaching this format is I don't get to look at people's faces whenever I start doing that hoe thing. It's funny when I can look at people's faces. Because after a while, it gets less and less funny, but it's hilarious to just the first couple of times to look at people's reactions. I miss that. Now you're probably used to it, so it's not as funny, but it was probably shocking the first time you heard me say it there. So, okay. Did you say you want to see one more real quick, or what was the verdict? But like I said, you're going to see that part. And looks like they're all about the same, except we got to do that part. So, but I guess theoretically you could. Is there? I mean, I guess you guys know how to do this better than me. I guess you can, but it's kind of a pain in the butt, isn't it? You can kind of miss it on purpose and then go. Can you go further in the question and then come back to it, or?
Yeah, I think it does. Like sometimes I leave it where I left off, like I was following what you were doing, and then I just come back to it where I left off.
You can get, in other words, if you're going like from a part A to a part B, and like I said, if you get the test statistic and you're not sure what's going on here, these next two things, can you?
No, we can't continue. We have to finish that one.
In other words, to get down to the p-value part. God, I wish they would have done the p-value first. That would have been a lot better. Because then there could have been like a part A, and we could have just completed the part A for every one of those. But I wish they'd let you jump around, you know, whatever problem part you pick. So, well, like I said, we can't do. I mean, it would take me too long now to run through how to do it, unless you just want to try to look at it yourself, but you're going to get the explanation next Wednesday for sure. Kind of hold you up a little bit, but you still got 9.1 you could do, right? So maybe I will open up the homework pretty soon, because that way, let's say if you do 9.1 and then you want to go back to other stuff, you know, that's not a bad idea, actually. You want to go back to earlier stuff until we finish this and then come back to this. Does that make sense? I don't know if that made sense or not.
Yes.
I might be delirious at this point. I don't know. So you can even go back and work at older stuff, because I'd hate for somebody, let's say if they've done everything, you know, all the homework, and then they're boom, they knock out 9.1 and they're stuck with nothing to do until after next Wednesday, and they wanted to do more. But if I open up the whole old stuff that you haven't done, you could, well, if somebody's that ambitious, they could probably look at the notes and try to figure it out, you know, if they wanted to. So, all right, if you want me to do one more of these, I can for today. Like I said, we're going to see, because next week we'll do the entire problem, you know, all of it, you know, so same problem. So if not, so we just call it a week. Is that okay? And I'll stick around for any questions you may have.
I think that one problem was good, but I don't know if someone else wants.
Right, yeah, you're nice. You don't want to speak for everybody, but I don't know. Maybe I'll just do one more real quick or something. It doesn't take that long, obviously. So one more, and then we'll say that's it for sure. They don't just pick any one of these. It doesn't really matter. Let's see. I'm gonna pick one that's. I'll do the credit card balance one here. I'll do the, because doing the hoe and the ha here is always helpful. Kind of blah, 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 blah. College students who have credit cards have an average credit card balance of 1066. Of means equal. Equal is a hoe. 66. And then not equal. Now let me ask you this regarding homework. Since this is the first part of the problem. Could you do these two pieces and still skip ahead to other problems and come back?
Yes, that's what I do.
Right. Yeah,
I just wait for you to.
The problem with the way it was, what I was talking about is I was trying to jump over something. But if you wanted to practice something, you could practice getting all these ho and ha statements set up if you wanted to. And then if you do the calculator, you would just want to get your test statistic and then write down, so you don't have to do it again later, is write down the p-value, because you know that's going to be asked coming up, so I don't know, is that helpful? Maybe that's one way you could do it. And then you can't go to the p-value, obviously, because we can't, you've clarified to me that we can't skip over. That makes total sense, actually, unfortunately. So what is this one? So 1066. Let's see what the standard deviation is. 276. Oh, the average of the sample was 1387. N is 50. And this is an equal, not equal. So I could hit enter there now to get the p-value right. Well, we're not going to be able to answer it now. So I guess they're, ooh, holy cow. Well, e in the negative 16, that's just a bunch of zeros in front of it. So whatever it asks for the number of decimal places, just put 0.000, however many it wants for that one. But it's going to be a bunch of zeros. So let's see, unless I did something wrong. If my test statistic is right, then the p-value is right. Well, let's check. 8.22. Yeah, so if it's asking you the p-value, 2 decimal places, you would just put 0.00. Okay, that's what it'll be then. I could actually finish this problem because I know how to do it. Let's see, what is this? 5%, two-tail, 1.96. You're going to be excited to learn how that works, aren't you?
So you went to the t-distribution, or?
Yep. Yep. It's going to be that two-tailed. We're going to learn how to read that two-tailed, one-tailed. So we know how to do the confidence levels, but we're going to learn what these two rows, so the confidence, these two rows are below it, are right for hypothesis testing. So it's two-tailed 0.05. Two-tailed is always going to have a plus and a minus. But that's why you got to be careful. One tail means left tailed or right tailed. So you got to make sure just because it's 0.05, you got to pick the right 0.05. That'll be the key. So I'll go over that in full detail, obviously. But, so you got to be, that's why you got to just not be careful which 0.05 you pick. All right, let's see. I think I did it right here. But I want to get to that p-value part of that. So excellent. Because the test statistic is, this sometimes can be tricky, does not fall, or you can say it does not fall within the critical values, we reject. Because it means it's not between negative 1.96 and 1.96 way outside. And then now here's where it'll ask for the p-value. 3 decimals, no problem. I can put a 0 in there 3 times. 0.000. Boom. Excellent. Okay. So all you need to do is learn that, we'll learn that one part there, so now you're kind of curious, aren't you, on that part? So I thought about maybe that was the wrong way to do this. Maybe I should have gone faster just to make sure I finished this section. And that way it would have made more sense. But I was just trying to split the workload up to where, that way next week won't be so bad. All right. Well, I'm going to go and, other than fielding questions, I think that's it lecture wise. So let's just see whatever I can help you with. Anything you may have here.
I just had a quick question about the major Excel project.
Oh,
Are
God,
we?
I forgot to send that woman an email. Thanks for reminding me. I got to send that woman an email tonight. I know nothing because I haven't seen it yet. Well, I haven't checked my email today. Maybe something's come or whatever. But if I've got any information, I'll let you know as soon as I get it. But I'm at the mercy of whatever happens here. But they need to step on it. I need a chance to look at it. And I want to see what's going on with it and that sort of thing. So unless it came, well, I'll tell you what, if it came in my email today, I'll go check and then I'll announce it in Blackboard. That's what I've been under the weather here. I've been forgetting to ask about that. So I hate that I'm at the mercy of someone else for this. So well, I guess I didn't let you finish your question, but the point is, I mean, I don't know anything yet, so as soon as I do, I'll let you know. So, but it bugs me that they should, if they're going to do this, get this ready earlier.
Okay. Well, thank you very much. I really appreciate it.
Well, thank you. I wish I could know more about that. It bugs me too. It upsets me. I want to make sure people are prepared. I want to make sure that that if it's bad news, I can come up with some sort of helpful guidance here to help you get through it. That sort of thing. Because if I have to, put up some instructions or something, I want to make sure I have enough time to do that. So I might make a separate video that doesn't, not a, participation video, just a separate video on what you're supposed to do once I see, but I don't know what it is yet. So, all right. So yeah, I don't know anything there, but okay. Hopefully that'll get going pretty soon. What else can I help you with here today?
Hi, Professor. I have a question, but it's for section 7.2.
Okay, well, absolutely. That's what we're after class time now, so it can be from whatever. So sure.
Okay. And it was for question 3.
Okay, give me a second to open it up here.
Yeah.
Yeah, that's what we're doing now. We're just kind of whatever. Questions about anything? That's what the end of the class here is perfect for, that kind of stuff. Number 3.
Yes.
All right, let me see if there's anything in the.
And it was for the last D, the part D.
All right. This one over. Okay. Thanks. So yeah, hopefully I will. Oh, you have a good evening too. Let's see. All right. Sampling distribution. Normally distributed samples of size, well, not uniform, will be approximately normal because it's normally distributed. So you're waiting to get to the last part of this. Is that what you're saying?
Yeah. So I finished doing that part, but I got stuck on.
I guess I could just show the completed. Well, I can do the whole. Doesn't really matter. I wonder if I could just show the completed problem because I'll have different. If it's a numerical problem, I'll have. Oh yeah. This is one that I mentioned last week that treat that problem as a confidence interval, even though it's in 7.2. Do it as a 60% confidence interval. And then I don't know if you've looked at the confidence interval stuff, but you'll need to look at that. I mean, I can explain it. Otherwise, it's easier if you do it as a confidence interval by doing a Z interval. Yeah, that's. I mean, there's another way I can show you to do it, but this is easier if you just do it as a confidence interval. Do it as a 60%. So I'll just do the numbers for this one. The mean is 2.66. No, standard deviation is 0.05. 2.66. N is 11, and then do it as a 0.6 confidence interval. And then rounded to 2 decimal places, it matches what I have. 2.6, if you round this, it's 2.65 to 2.67.
Yeah, I got it. Thank you, Professor.
You're very welcome. So yeah, that was a weird problem. Yeah, that was a good question.
Okay. Thank you.
You're welcome. Now serving. Uh-oh, only one left.
I think it's just me, Professor.
All right, that's okay.
Thank you. Have a good night.
Okay, all right, yeah, you're the only one talking. So let's see. You good? You need anything?
Yeah. No, that's about it.
All right, terrific. We'll see you next week.
Thank you.
You're very welcome. Bye-bye. Okay, let's see. And